In my first job as a mechanical engineer, I did not use every single concept that I learned in college. Like many recent engineering grads, I thought that I would have to know it all, when in reality, that turned out not to be true. And I did make mistakes in the process, but I must tell you that I did enjoy my first experience very, very much in industry. So in this video, I'm actually going to walk you through my entire experience in my first job as a fresher / entry-level / junior engineering graduate. And all of this information is going to help you know what to expect when you enter industry, and not only that, of course, so that you can make your own experience more successful. But hey, let's get right into it. And if you're new to the channel, welcome. My name is Alex Isidro, and here I share engineering career and purpose content to help you develop professionally and personally. So if you enjoy these types of videos, make sure that you smash the like button right now and consider subscribing. Okay, with all that being said, let's jump right into it. Entry level is basically the lowest position that you can find in a company. Now, when it comes to us engineers, when we join the engineering field, you're going to be entering as a rookie, right? You're at the bottom of the hierarchy, you're at the bottom of the ladder. And then over time, as you gain more experience, you gain other skills per se, or you improve your skills, then you slowly start going up the corporate ladder. So now that we have an understanding and an idea of what entry level means, when I entered the engineering industry, it was into the naval industry, specifically defense. So the really cool thing about entering this government program as an entry level engineer was the fact that I actually entered a rotational program. And it was actually also a ladder per se, because number one, it was a rotational program in such a way that once I started working, I was going to be exposed throughout a 3-year period. I was going to be exposed to different fields and different parts of the organization. I was going to go from logistics to technical to industrial sites, and then eventually I ended up leaving before I finished my rotational program, but that was the original goal. Now, when I say ladder, it means that as long as I did my job and as long as I actually did what I was supposed to do and perform and deliver results, I was going to get promoted to a higher rank and also a higher level of salary. And so with respect to the salary itself for the Washington DC area back then, I was earning $54,000 a year. Now, if you really think about it, after taxes, it was really not that much, but luckily I was living with my parents for the first couple of years, and so I was able to not really save up that much money because I had a lot of loans to pay off, but it was enough for me to make a living and actually establish myself in the Washington DC area after college. Now, when I mentioned the ladder journey within this organization, I was gonna go from $54,000 all the way to $90,000. That was the goal in 3.5 years, and that's actually one of the enticing parts about this program, because I don't know how it is for other engineers out there in industry. Like, I mean, I have an idea now, but back then I didn't really know how much engineers were expected to get after a couple of years of experience on the field. And so having this idea or this goal of 92,000 or approximately 90,000 after 3.5 years, for me, it was a huge accomplishment, and I was actually very, very much looking forward to all the promotions that I was going to get. Now, when it comes to the dress code, it was simply just like your regular tie and your regular slacks. Depending on what you had going on, a lot of people would just wear suits, or some people would just wear like the regular, like the typical engineering attire, which is like your polo shirt, khakis. So it really depends on who you wear, what you had going on. If you had to meet with clients, or if you had important meetings, obviously you'll wear suits. But generally speaking, personally, most of the time I used to just wear a shirt, a tie, and slacks. Oh, by the way, also with respect to the dress code, if you were scheduled to go on site and go to the ships, the surface ships, which are the things that we worked on and we helped out with, then obviously you have to wear your steel toe boots, and then the regular attire for someone that's going out there to the boats is steel toe boots, khakis, and a polo shirt, or obviously like any type of coats or anything that you may need depending on how cold it is, and also like where you are. Sometimes you go down south in the United States and it gets really hot, and good luck with that. When it comes to the schedule itself, A lot of people, it really depends on what you wanted. Back then, the company, or not company, the organization, the government organization that I worked for, allowed us to work on a flex schedule. That's what they call it. And what that means is basically having a 3-day weekend every other week. And you achieve this by working 9 hours for 8 days, and then working an 8-hour shift. And that way you work 80 hours in 2 weeks, and you average 40 hours a week. So that was a nice perk per se, definitely, because then you would get a 3-day weekend every other week, and that was awesome. I went from Fridays and then eventually ended up switching to taking Mondays off, and having a 3-day weekend every other week was a really, really sweet perk. So when it comes to the stress level of the job itself, it really wasn't that stressful most of the time. However, I do want to say that there were times when you had a lot of deadlines when it comes to writing reports, or maybe you had to do, because I was dealing with contracts in my first rotation, which I'll go over in a second. There were some reviews that I had to finish very, very quickly, and I had to work with other engineers. And so that review process, which was very short timeline, and so that spiked up the stress levels for quite a bit. But most of the time the work actually came in waves. Like there were times when you were slammed, and then it would have slowed down for a bit, and then you would get slammed again. So personally, I'd rather have that than being stressed out all the time or being slow all the time. Now, when it comes to the work itself, I was basically helping out with 2 programs. The first one was logistics, which entailed a lot of contract management, a lot of making sure people that we were supporting, all the boats that we were supporting, making sure we made all the logistical arrangements so that they could have supply of lube oil or lubricants in general. And then the second part of that first position was actually working with diesel engines and lube oil analysis, lubricant analysis. It was actually the first time I understood how important lubricants are for mechanical systems. Like a lot of times we really don't think about those things. We think about the electrical systems, the mechanical systems, all the moving parts, but we don't understand that those moving parts are moving obviously because they have oil, and the oil needs to be changed on time. The oil needs to be changed based on how well it's performing. If the oil is dirty, it can damage the equipment, it can damage the machinery, that especially if it's rotating, if it's moving, if there's a lot of moving parts. Obviously the oil has to be very, very clean, it has to be purified, it has to be filtered, and also it has to perform at its best all the time. So my team and I, we were actually in charge of analyzing the lubricants that the ship would send to a lab, and the lab would obviously analyze and will give us the chemical composition. They will give us the physical properties of the viscosity of the lubricant, and they will give us a report with all those parameters, and then we will, based on those parameters, we would make recommendations to the ship so that they in turn could provide the proper maintenance for all the equipment they had on board. And I also got to work with oil companies, doing lubricant analysis with contractors. I was working with a professor who was very, very patient. He actually gave me a lot of insight, and he kind of mentored me into the position. I was working with chemists. I was working with experts on lubricants, and I definitely learned a lot from them. The other thing that I did as a mechanical engineer when at my entry-level position here in the logistics and contract management and lubricant oil analysis department, I also led a study on diesel engines, and I actually ended up writing a technical report that unfortunately no longer have, but not that I can show it to you anyways, but it just goes to show how much your technical writing skills matter when you join industry, not only for this report, but also because of my program, I was required to submit a technical report on everything that I had done, all my accomplishments, all my plans. And so all the technical writing skills that I actually learned in school came in very, very, very handy, to the point that I actually even got complimented for the reports that I was submitting. So it was actually, I mean, back then, obviously I was a young engineer, so it felt very, very good to get that compliment and say, you know what, like that was a really good report. So that definitely meant a lot, and definitely boosted my confidence. There wasn't really that much travel with this position. If you are interested in knowing how much travel you will be doing for your specific job, that's really going to depend on your position, like what you have going on, your client, your company. So for me, it was probably about like 5 to 10% travel. It really wasn't that much, but I have been in other positions where there was a lot of travel required. After that, I also ended up working on more technical stuff. Eventually, as I mentioned earlier, there was a rotational program. So that was the first part. And the second part was more technical. It was more drawings related. I did end up using AutoCAD Mechanical for quite a few months. And it was more related to mechanical devices, like how to draw, like making some reparations and making some installations of equipment. And so I was in charge of outlining and demonstrating all the different parts, everything that needed to be done, any welding, dimensions that needed to be pointed out on a drawing. So I developed all of that. And the most exciting part about that technical branch was that I actually got to go on site. I went to South Carolina for a couple of months and I actually ended up working on a ship, and that was very, very insightful. And I was actually helping out as an assistant port engineer. And if you never heard of a port engineer, they're basically engineers that are in charge of the work that takes place in ports. Like, they deal mainly with the naval industry. So I was there for a couple of months where I was racking up overtime. I was working long hours, at least 10-12 hours every day, and it was very, very hands-on. A lot of like stains on your clothes, and it was like you get dirty. Like, once you go actually on site, I mean, construction people know exactly what I'm talking about. Or if you ever been on site, like once engineers go on site, like you don't go there to hang out and like you don't stay clean. Because for my job specifically, for that specific position, I had to go into like little like manholes, and we had to inspect tanks, fuel tanks. We had to inspect diesel engines, boilers, compressors, like separators. So all these mechanical devices are obviously, there's a lot of oil involved, and like you get dirty. And so it was just normal. Like, I mean, it really wasn't, not that I don't want to get dirty. Let me just make that clear. But that's just some insight that I wanted to share with you for the purposes of this video. So you can see that the ship is actually on blocks. It's dry docked. First time I see a dry dock, actually. See people working on it. Right there. Little man lift. The ship is huge. Apparently it's bigger than the Titanic. Only a few feet bigger than the Titanic length and beam. Beam, which is the height of the ship. So, cool facts. So that was probably the best part of my experience as an entry-level engineer, actually going on site and applying or seeing how all the applications of engineering take place, how they perform. It was a really, really great experience to interact with experts, with electricians, with machinists, with welders. So that was basically my experience on the job itself for my entry-level position as a mechanical engineer. That approximately lasted about 3 years, and until after that time, I ended up leaving the government and ended up going somewhere else. Now, let's talk about how did I adapt and what it was like, how rough it was transitioning from college and all the work to going to work 40, 50 hours a week for my full-time job and actually getting paid to do engineering work, you know. So in the beginning, it was a little rough because I didn't really know what to expect, although I did have a little bit of experience from my internships, and from the previous year I already knew some people from the organization, and so it really wasn't that terrible meeting the new people. But and also once I actually got to know the job, I really wasn't trained or anything. The first couple of months were a little rough. I was kind of trained by the fire hose method, which basically entails you getting asked all these questions and then you're forced to figure out what to do and how to provide a solution. So it entailed going out to people and reaching out and introducing myself and saying, hey, I'm so and so, like I'm new here, I'm trying to figure things out. It's like, could you help me? Do you mind giving me some insight, some advice? And so luckily for me, there were a lot of engineers that were really, really helpful and were able, and they made the time to give me insight. So now let's talk about the preparation that engineering school gave me. And the first thing that I want to say is that the analytical skills that I learned in engineering school definitely helped me a lot, especially when I ran that study for two things mainly. Mainly because I was dealing with data, but there were two parts of this. Number one, I was dealing a lot with lubricants and all the data and all the analysis of lubricants, and that means viscosity, that means chemical composition. And when you analyze these different parameters over time, then you start looking at trends, you start looking at different points, and you have to make projections or figure out what happened. And so all that training and engineering that I had for the last couple of years definitely helped me with that and understanding that right off the bat. Not only that, but also when I ran my own study on diesel engines for fuel dilution, which is basically fuel contamination, I also did a similar analysis on fuel composition, chemical composition, properties. And so I had to do a lot of research and finding out parameters and analyzing those parameters and making projections and figure out what could actually be going wrong and why the fuel is getting contaminated. So all the research skills, all the analytical skills definitely helped me a great deal, and I am very grateful for school. Also, the technical writing skills that I learned in school for writing the reports, not only for my personal development career back then within the organization, but also for submitting technical reports for the job that I was completing and doing. And not to mention, all the math background helped me a great deal with generating patterns and data analysis. So I think I already mentioned this enough. And so the next part I'm going to mention here is, did I make any mistakes? Did I make any mistakes? Because that's one of the things that I think as young engineers, that's one of the things that we are the most afraid of. A lot of times we come into industry with this imposter syndrome, and so we don't know what to expect. So did I make any mistakes? Of course, I made a lot of mistakes when I was making recommendations based on the analysis that I was doing. One time I got called out by a chief engineer on a boat. I was doing the analysis of lubricants wrong, and I just told this chief engineer to change the oil of his diesel engine because the oil showed patterns that it was dirty, it was contaminated, the viscosity was too high, and so that could potentially damage the equipment. So he needed to change the oil. The problem was that I made this recommendation one too many times. And as a young engineer, a lot of times you assume things, and maybe you are rushing through things, or you don't want to ask. And so I went with what I thought was right. However, immediately after I sent that email, I remember in the report and everything that the chief engineer needed to know, he came back to me and said, this is the third time I've changed the oil in this month. And you know what happens when I change the oil? This takes days to change the oil because I didn't really know back then, and this is a rookie mistake, but these engines were huge. Like these engines, like their oil sump, that's what they call them, the oil sump is it's like hundreds of gallons of oil that they have in these engines. And so changing the oil of that, you have to pump out the oil, and that takes a long time. And so it's an incredible effort to just change the oil for these huge pieces of equipment. And so from there, I learned my lesson to actually double check the work, talk to an expert before, someone that has more experience, before I just make a decision on my own, especially as a rookie, young and new on the field. And also the mistakes that I made also led me to understand the importance of communication with other people. So that's the bottom line there. Like if you're not sure about something, don't just go for it. Don't make assumptions. I've said this in the past in the channel, and this is because it was a lesson learned in my own journey, that don't assume things. I just make sure that you double check with other people, because if you assume and you're wrong, that can lead to costly mistakes of time and money. And so what are some lessons that you can take away here from this video? The first one I want to say is that don't think that all engineers are always just working on design, on drawings, or number crunching, because those are not the only places where engineers are needed. We're also needed for doing data analysis, like as I mentioned, also for doing studies, also for writing reports. But the report usually comes after you do something, because you communicate on results of a certain study. Also, you'll be dealing with lots of presentations, and so communication is definitely going to be very crucial. You can also be working in industrial sites, maybe more hands-on, and you're going to be leading projects, dealing with contracts, which is something that I did. So engineers, I needed in a wide variety of fields, not just for number crunching and doing design work. So keep that in mind, because this can also help you expand your job search in case you are looking only for design positions. The other thing that I want to mention here is that one good thing to know prior to working for a certain company, I think it's definitely to see if the company that you are trying to work for, or the company that is offering you a job, figure out whether or not they offer a rotational program. I think a rotational program is crucial. Well, not crucial, but it's definitely important in my opinion, especially when you are a young engineer, because at that point you're exposed to many different fields and not just stuck in one. Now, if that's your thing, if you're just grateful to get a job and an opportunity, then go for it. Don't be too picky. But if you want to kind of maximize your experience, and there's a company out there that provides these rotational programs, I think it's worth taking advantage of. Also, the other thing to pay attention to is ask for the promotion potential or potential for growth within a company. See what kind of chances or opportunities there will be within the company to increase your salary, to grow your skills, because I think they can also help you make a better decision when you are down selecting if you have multiple offers. Now, of course, if you just have one offer, like I mentioned, just be grateful for that and just take it right away, and then worry about that for your next position down the road. Also, by the way, something that you could take into account is like once you are hired, and I'm saying this like once you're hired, ask what kind of schedule options the company has. Maybe you can take advantage of a certain schedule, a flexible schedule. Maybe you can take a 3-day weekend every other week. So who knows? So ask about that, but don't push it too hard. You know, if you're new and you're just kind of, if you're not sure whether to ask or not, maybe just wait a little bit until people know you and just you figure things out. But I think it's something to consider. Now, the other thing to take into account is try to find out whether or not you'll be assigned a mentor when you go into a certain company when you're new. So get a mentor if you can. If not, find out if you're gonna get one. But if not, don't worry. Pay attention to other people, listen, ask questions, and if you're not sure about something, don't just assume things. Make sure you actually ask and double check with other people.
So now, of course, this has been my experience, and keep in mind that everyone is going to be different. The industry that you get into is going to be different, but there are overarching themes that I aimed at helping you understand through this video. But if you want to know more about what to expect, or the mistakes that I made in the process and the regrets that I made in 10 years as a mechanical engineer, go watch this video right here where I tell you everything that you need to know. I'll see you guys on the other side. Peace.